Good afternoon, everyone. I think post lunch I'll try to keep it as much interested as kind of a storyline. I may not be going through every portfolio of a storage, especially in this session. I will try to cover data center piece of it. Right? There are other portfolios, client side we have, embedded we have, which are all outside of this discussion, and so how, in the data center space, how memory and storage are going to marry each other, and what are all the different changes which we are expected. And there are new paradigm shift which is going to happen. And in due course, we've been hearing data, right? So everywhere data is getting exploded, right? And how we are going to get the benefit of a data, even every larger enterprise, how they need to understand the data and integrate it across the platform, and how we are going to really get the value out of the data. So when we talk about more on data, then ideally the storage and the memory is a key partner where it needs to get the speed to get the data to process it. So this is a typical legal disclaimer where we have it. Where our legal team, without this deck, nothing goes public. So this is where everyday data, right? So on a left, from the end user till the enterprise, how it's invariably increasing. So actually this projection was 2020, but we are pervasively seeing this data growth. In fact, one of the data which says in India, we crossed 30% of our data internet user in last 2 to 3 quarters because of a large telcos data provisioning, and that's where even 10 GB, even nowadays we are averaging using the 2 GB in each telcos, right? So that's going to be increase. And the next is autonomous driving, where we see close about 50 TB, where 50 GB of data per day, where I was in a previous role with one of the leading auto car maker. The interesting is they have 2 vehicles which is already on the telemetrics, not even autonomous driving. I'm not talking about autonomous driving. 2 vehicles which is telemetrics connected, and their monthly cloud, probably the projected cloud rate of volume is 6 million business, right? They don't talk about anything on the cameras, they don't talk about LiDAR, they don't talk about radar at this point in time, just info entertainment and the telemetrics. That itself huge business, and the data which they are trying to monetize, 20 different ways they have a business model, how to monetize the data. So in the sense, all the data, raw data comes into a data center, it needs to really have a deeper insight, and it needs to take in a different level of a business. Then only data become a real business to a enterprise. And obviously smart hospitals, which is 3 terabytes per day. And interestingly, Boeing, which is having a 5,000 sensors in their engine itself, turbulence itself, which are all data, right? Again, in a double-decker airplanes, they have a 10,000 sensors on their wings, which is all going to be a data-generating engines. And smart factories, already we are seeing industry is Industry 4.0, where a lot of a smart factory and a lot of a smart logistics we see, right? What's in it? Really, all this data needs to be moved towards meaningful conversion. Any guesses? What is this? Okay. So this is 2017 Alibaba's 24 hours sale day, right? And they have a 15 million products, and the orders been 8-12 million orders. It's been shipped on the same day. And a payment, which again, it inclusive their vendor payments and put together, because if you look at it, the orders are 8-12 million and the payments goes 1.5 million close to. So which is altogether the ecosystem payments, which is higher than the product sale. And the overall, the sale which has happened is 25 million. And if you compare the 20 Previous year, it was 17 million. So the transaction is get growing, and they have needs to have such a agile system to support this sort of a transaction and the volume, right? All right, so in Intel, we talk about temperature. I think I heard some of the colleagues talks about in previous session, data temperature, right? So cold, warm, and hot storage. And within these temperature, because even in large enterprise have a practice, hey, I need a 8 petabyte, I need a 10 petabyte needs to be provisioned. That's the sort of a requirement we used to get it from the customer, right? And now that equation changed, completely changed. No more customer asking, hey, I need a consolidated capacity, you provision for it. Now the customers are intelligent and they were asking and demanding based on the workload, based on their solution, they are going with a different tier, which is giving a best benefit to their cost, because that's where it come to, right? So the hotter data which we see, which is very closer to CPU, and DRAM is at this point in time, in any architecture, hotter data, which is a very low latency and high throughput on a hotter data, which is a DRAM. And warm data, which is away from a DRAM, we call it SSD, probably, right? And the colder data is archival data, and most of the cloud service providers are leveraging that. And this is where these temperature and Intel plays a role in it. If you look at on the left, so there is a 3D NAND. Sorry. So these are the two different portfolios, right? On the left, you will see 3D NAND technology, which is more on the any SSD. You call it any SSD that goes in, which is a warm tier of data collection. And on the right, which is Optane technology, where predominantly I will talk about more in detail about Optane technology. How many of you in the crowd know about Optane technology? Okay, very few. All right, so we'll talk about more in detail what medium it is, right? How it helps takes the data such a near to RAM capacity, or even near to RAM performance or low latency and high throughput. And we talk about a QoS, right? So which gives a far better QoS on the Optane technology. So that's again, right? We do a trade-off between the DRAM, SSDs, and HDD based on the performance and the cost. That's a trade-off happening. And if you need a high performance throughput, then ideally closer to CPU, and SSDs and Optane is a way forward to go. Here, if you look at it closer to CPU, where you will see DRAM and Apache DIMM slot. This medium is completely different from SSD medium. Like people who knows since the SSD, you will have a flash drives within which, right? And that's been made up of your memory cells, and the memory cells which stores the data. Ideally, that's your 3D NAND. And there are, of course, a previous generation. There is a QLC coming up in the 3D. There is a transformation in the 3D NAND segment that is going on. That's a warm tier of the data. And Optane, the medium itself completely different, right? So when we do a SSD, the bottleneck is the write intensive, where I have a heavy write intensive, and even in SSDs, we hear customers like, hey, there is a bottleneck on the write. Because you need to do a race coder, because of it needs to have a garbage collection. And wherein it won't, without a garbage collection, even in SSDs, that medium won't support to write it. That's where you see a bottleneck. Wherein which in Optane, you don't really need to do a garbage collection or even a race coder, rather than bit addressing, zeros and ones which goes directly to the memory cells, right? That is where if you can closely compare to the RAM, right? And that's the difference between the 3D NAND and the Optane technology, which we call it 3D Crosspoint. And ideally, this fits into PCI slots. All these drives fits into the PCI slot that can be act as a DRAM that replace your DRAM, right? I will have a video where our executive talks about how Octane evolved over the period.
4+ decades. That's how long it's been since the last truly revolutionary disruptive memory technology was invented. But that's about to change.
The quest for getting data closer to the CPU or solving the problem of the data and the CPU not always being together has been around since the origination of computing, since von Neumann originally did some of his work.
Probably the last real breakthrough in memory storage, if I was to characterize it, would have been in the early 70s. I mean, if you look at the three main kinds of memory that exist today, the predecessor of flash was really the UV-proms that were developed in that time period. DRAM was developed in the late 60s, and it still is fundamentally the same. Really nothing substantially new has really occurred since that time period.
All the while, data growth is exploding, roughly doubling every 2 years. And those massive volumes of data must not only be stored, but analyzed to extract meaning, value, and insight.
We all know that there's more and more data in the world. And the more data that there is, the more processing you're going to want to do on that data.
Faster storage is important to computing because computing is done on data and data is put in storage. The longer it takes to get to that data, the slower the computing goes.
So high-performance computing has always been very data-hungry, and the larger the data sets we can handle for HPC applications, the better science we're going to be able to do.
But therein lies the problem. Even today's fastest storage memory is roughly 10,000 times slower than the fastest CPU memory, resulting in a performance-crushing penalty each time data is accessed from storage. We desperately need faster storage memory.
Computer architecture from its days of von Neumann hasn't changed significantly, in the sense that it still has the same basic components.
There are a bunch of memory technologies in a computer. All the way from registers in a CPU. There are actually 3 levels of cache in a CPU die itself, where some of the levels are closer and more expensive and faster, and then they get bigger and a little bit farther away from even inside the chip, there's close and far. And then you get off the chip, and today you have DRAM, and then you have NAND SSDs, and then you could have hard drives also that are even farther away.
So we want to get as much of the data as close to the CPU as we possibly can. And if we can get that data to be faster, then the CPU waits less for that data.
For decades, engineers around the globe, including multiple teams at Intel, have been racing to design that next breakthrough memory technology. Many have questioned whether it's even possible. But now, Intel engineers have realized that breakthrough with Intel Optane technology, a unique combination of Intel's advanced system memory controllers, interface hardware, and software with revolutionary 3D Crosspoint Memory.
3D Crosspoint is going to bring a lot of exciting capability. It really starts to marry the worlds of memory and storage together.
So with 3D Crosspoint, we can really have the 3 values that's most valuable both out of DRAM and out of the solid-state drives. So we can take what was previously multiple layers of a memory hierarchy and concatenate them down into essentially just one layer.
And so for the first time, the 3D Crosspoint technology will allow you to combine both memory and storage into one memory device.
With 3D Crosspoint technology, the performance that it delivers, it's kind of a once-in-a-lifetime sort of thing. I mean, it's literally, this hasn't come by in several decades.
It really is going to unleash software designers, system designers, into new systems and new capabilities that we don't even understand yet.
Well, Intel's new memory technology comes close to being the holy grail of memory. It's cheaper than DRAM, it's way faster than NAND, and it's non-volatile. So it's getting pretty close to that ideal memory.
We heard about Optane technology, right? How if you look at on the left, we have SRAM, DRAM, which is existing, and low latency and high throughput. And the limitation is the capacity. You can't go beyond 120 gig, 28 gig in a server, right? And on a right-hand side, NAND and HDD, where 3D NAND SSDs will have a high capacity, but the latency would be much lower than the DRAM, right? So where we see a real potential and a gap between the price point as well as the capacity and the latency. So that's where the 3D Crosspoint plays a role. And if you look at it, we talked about a high endurance, and usually when we talk about high, read-write intensive workloads, we talk about at the moment five writes per day, right? So ideally, that's industry speaking. So we are obtained close about 10 drive writes per day in Octane, and 30 drives writes per day in the current generation, which is available. You go and talk to the partners, OEMs, or even ISVs. They would have a better idea on the drive writes per day. And IOPS, it can't be matchable with SSD, right? And in QoS is really high, and that is where it is playing a role in between the DRAM and the SSD. So, what is today? Today we see a lot of cache, like even in current CSP customers or telco customers we are discussing, and ISVs, right? You can take any SDS environment, we need 10% of a cache on the caching tier, right? And with Optane, if you go with any SSD, probably the thumb rule is 10% of cache tier on your SDS environment, being it your Ceph or your vSAN environment. But with Optane, you can go with 5% of a cache, right? And there is a transformation which is going on with the ISVs and the OEMs. You can talk to your OEM partners and ISV partners. They should be aware of it now, where I'm making VMware, Nutanix, and even Hyperflux, for composable environment, we are making the cache tier, which gives a direct benefit to your TCO. And other interesting features, the architecture which is going to get changed is now we are seeing the Optane drive in the PCA slot, the form factor which you are getting in the PCA form factor. In future, which is on a Q4, you will be getting an announcement from Intel that we are going to have a DIMM slots, right? You have a RAM DIMM slots, where in which the same medium, the same technology, but the form factor is going to be your DIMM slots, and that will replace a higher capacity, where if you ask me the capacity, probably 1 TB to 2 TB of a capacities, you're going to provision at the DIMM slots itself. So that is a change where there is a, in Apache Pass, I'm not going to go detail in this session. Probably Intel will be announcing to the press in a week time. You will be hearing the complete detail of it. That runs on 2 modes. One is a memory mode and app direct mode. And we are working with the ecosystem to enable their application, being it your DB or being it your SAP. They are doing optimization with Apache Pass. So I will talk about more in detail about the Octane in this session, because that's a product exists in the market and available for you folks. So this is a broader portfolio. How many of you know, Intel has a SSDs? Okay, quite a few, because when I go and talk to multiple partners, they know, they recognize Intel as a CPU company, right? And we are transforming from a PC company to a data center company. So that's going in, and you see, this is a broader portfolio on the SSD. You can name it, at this point in time, we call it one as a block storage and the typical server architecture, right? You will hear all these portfolios on the server architecture. Even in a block storage, there are early adopters like Dell EMC, HP3 powered Nutanix is 100% on Intel SSDs. And on our top is more on the Optane technology. This is a PCIe form factor. This one is a DIMM slot, which I talked about, where it will replace your RAM, right? Some of your RAMs can get replaced. And even in this case, you have a high capacity. Current available capacity is 700 gig, and you will be seeing in Q4 1.6 or 3.2 TB of capacity available for PCIe slot that can be converted as a DRAM. I will talk about in detail that. Right? And we have a PCIe NVMe drives, which both write intensive and read intensive. And here, this is NVMe Octane drive is for more on the caching tier, right? And here the SATA for high capacity. And ideally, we see a form factor which is coming up where you see 32 TB of a single device will hold the capacity. So that's a ruler form factor, right? This is a 3D NAND, not Optane technology, but 3D NAND. With this, you will have, this is a EDSF form factor, a consortium where they have a standard form factor. If you look at it, it's a pencil battery and the scale ruler size. That's the size of it. And the other one which is coming up, you will be hearing in a Q1 2019, which is half scale. And again, we are taking a high dense and putting a higher capacity, bringing the high capacity in the smaller form factor. Another advantage in this is serviceability. If you go and ask the data center specialist, the challenge is, hey, I have a hard drive failure happen, but I couldn't identify, because a lot of time it goes in the backlight. So in this form factor, you will see all the lights would be on the front, where the data center specialist would able to pull in if a hard drive fails, and if SSDs fail, then they can plug it in. So that's a serviceability they are getting out of it. Right. On the ruler form factor, if you look at it, 1 petabyte in one chassis, 1 unit of a chassis. So that's the maximum capacity we are bringing in for ruler form factor on SSD 3D NAND, right? Then you think of how much the whole rack, right? And that's where the data is going to get stored on. This is not every server at this point in time you will hear it about, but sooner most of the OEM will have the EDSFF form factor pluggable available on their servers as well. So, because when I go and talk to the customer, a lot of time they ask me, hey, you have a bunch of portfolios. Now you are playing a memory segment also, right? So what best for me to choose, right? This is a one slide at which I wanted to tell you, if you have a high IOPS, low latency, and high QoS and high endurance, then Optane is a way to go. And the capacity is minimal. I mean, you will see 750 gig, and you will see close about 1.6 TB. That's a restricted capacity on the current generation, right? On the downneath, where you will see 3D NAND SSDs, all NVMe SSDs, where you will get a better than the SATA SSDs IOPS, and the latency would be better, and you will have a higher capacity as well. So this is a math wherein which trade-off between your price point as well as your performance of the SSDs world. So little bit on the usage model. I talked about Optane drives, right? So there are 2 usage models. I will take the question post to the session in the interest of time. So these are the 2 models on my, on your left. If you look at the usage model 1, where you use Optane as a overall as a cache tier, and that fits into the PCIe slot. And you name it, a composed environment or a vSAN, SDS, you have a journal metadata that Optane goes in those tier. And the benefit is you don't need to go for a 10% rather than 5% of Optane because of the performance. It would able to scale at the level the performance is going to match. The other usage model is on the there are a lot of in-memory database coming up, being it Cassandra or a lot of big data Spark, which require a high memory capacity, right? And I've been hearing from a customer, hey, I have, because the memory price continue to spike and it is no longer going to stagger because of the demand. And that is where you will see the challenge and the business problem where the memory price continue growing. How can I take a control on it, right? So that's the second model would help to your business in terms of converting your PCI slot higher capacity PCI drives as your DRAM, right? How I can achieve it? There are two ways to achieve. One is IMDT, which is an Intel memory technology drive, which runs on your kernel, which converts your SSD Optane drives into a DRAM. And there is a Linux swap. There is in a Linux, if you look at a kernel 4.11, where that would also convert, a lot of CSP they were using a Linux kernel, and they converting the some of the PCI drives to a DRAM as a memory pool. And the performance between the IMDT and the Linux swap, there is a difference, and that's where the trade-off. We see 5x difference between using IMDT versus Linux swap. So I will give a broader view. What are the application which can fit in this landscape, right? In this slide, I just call out few things where we see a lot of customer are transforming from the traditional scale-up architecture to a scale-out architecture, especially on the storage side, where the cache tier is a major, where a lot of CSP and telco customers and even next-gen FSIs, they see the real benefits on the TCO in bringing a cache tier in the Optane technology. And cloud service providers, yes, the memory is a major bottleneck on the price point. So that is where it could be a VM, it could be your KVM, or it could be a Zen server. So all where there are real values where we see extending their memory and doing their swap memory on Optane. And databases, we see SAP HANA is going to implement. Soon you will be hearing the announcement on Octane technology. And MySQL and all the in-memory DB, Cassandra, Spark, on a big data landscape, right? They were all, now we see adoption on the Octane technology. And of course, there are Hpc workloads. Hpc workload is pretty tricky because we need to understand the Hpc workload, how this relates with the workload specific. If your read and write is more intensive and you're doing at the block level, then we need to really look at the large memory footprint, how we can leverage Optane technology. And CDN and the cognitive network and NFV, which are all early phases with telcos world, where the Optane technology adoption is on. I just want to call out a testimony from a customer, which is the University of Pisa, how they address their business problem through Optane technology. Can you play the video?
We collaborate with a medical foundation called Imago7, doing research on MRI, especially in degenerative diseases of brain. Now a researcher in there came up with the idea of undersampling, so getting less data from the machine and filling the gaps by using pre-computed tables. This approach is effective as long as you have a lot of memory, but actually current system does not allow the right amount of memory. So we try to expand this memory using Intel Optane technology.
We started deploying SSD drives and NVMe drives, and at last we decided to install Intel Optane drives in our scientific computing environment. The Intel Optane drives have low latency and fast speed, and we reached a lot of improvement in our scientific computation.
It can shrink down to 2 minutes examination process that took 40 minutes before, so this is really good for patients.
All right, so that's on the HPC workload, right? You heard that 40 minutes workload and their examination has shrink down to 2 minutes. Then how much of a memory intensive application which had run on earlier, and Optane brings a real value to the mankind, right? And since it's a developer conference, I thought to give a glimpse on the software portfolio. If you look at it on your left, which are all developer library on open source, just to highlight, many of you I heard that SPDK you guys been implementing, and that's open source on a upstream available based on our team doing the contribution towards SPDK. And another interesting library where CSP is adopting Intel Storage Acceleration Library, where some of the CSPs, they wanted to build their homegrown application and they want to really get the benefit of a storage, being it a compression or decompression, encryption. That's been a bottleneck for them, and through Intel storage acceleration library, they could get the best benefit out of the storage. And on the software product side, CAS is a cache acceleration library, which is more like in-memory database. Going with Octane and a cache, we see close about 10x of performance improvement. And even a lot of a typical transaction database, we see 10x of a performance by implementing a cache. Because it provides a lot of libraries at the kernel level, it enables a network to go and fastly fetch your data to a CPU. And how many of you heard about Vrock? Any of you? All right, so currently if you look at it, you guys been using a RAID card, right, on your any JBOD environment. No more, RAID card. Now a lot of telcos and again large enterprise, they were taking off the RAID card, and you can use a virtual RAID card, which is runs on the CPU. So this is a application or a package which runs on a CPU. You don't need a RAID card where that does the intelligence of through Vrock. And I think we talked about IMDT. IMDT is a package which converts your drive to display some of your DRAM use cases. And some of the profiling tool where you will have to benchmark or test Parallel Studio and the System Studios are. That's all. This is the last slide where one of my colleague who's running the startup program, and this is a plug-in program where we incubate the startups and we accelerate them, who are all the hardware and system startups, where we pull them to the ecosystem and we help them, guide them on the best ecosystem to go and scale for them. That's all I have. Any questions? Okay, I have 5 minutes to go. It's a software, right?
Oh, okay.
So whatever the intelligence your current RAID card does, right? Third-party RAID card. So with respect to the controller, it's been managed by Vrock. So that gives a direct benefit to the customer in terms of getting more TCO.
Server, they support the software RAID. So how this is different from the existing software RAID technology?
No, I think the intelligence is kept on the RAID, where it has a controlling which needs to be pulled on, which block needs to be pulled, and which needs to be go away from the RAID card. So in comparison to your question, in comparison with the other software, probably I need to explore that. I have most of them trying to do the same. In general, if you look at the RAID card, what it does, it brings a block, how frequent you are using. I think some of the colleague from Veritas talks about how the machine learning plays a role bring more accessible data to the layer, to the hot tier to get the access more, right? So it's more or less commodized application where you can compare, and the baseline algorithm could be the same.
Yeah, you talked about 1 terabyte of NVDIMM on the DIMM slots. So is this what type of interface it is? It is a DDR.
Say it again, I couldn't catch the first part of it.
You talked about 1 terabyte capacity of DIMM, right?
Yes.
Yeah. So what interface? Is it the
It's
DDR4?
A DIMM slot. It's a DIMM slot, DDR, I mean it fits into the DDR RAM.
So the interface is DDR4, 5 or some proprietary interface?
No, it is not a proprietary, it is a DDR4 interface.
Okay, so this Optane technology, right? This Optane technology. So what is it? Is it a substitute for this 3D NAND, or it's a?
No, it is going to complement it. If you look at the portfolio, it is going to be, see, the challenge is memory, right? So we wanted to really work out where the gap is, and we wanted to bring the 3D Crosspoint in which way. If you look at the higher capacity, hey, I want a single drive of 32 TB, right, which can't be provided by Octane in the sense. So it's ideally that goes with your typical SSD on NVMe or SATA base. So this address your, if you need a high throughput and the IOPS and the highly read intensive, then Octane is the case to go.
So that means whatever the capacity you are saying, 1.5 or 2 TB, it will not go beyond that, or what?
In Octane technology?
Yes, in Octane.
Okay, so in Octane technology, there are two ways to look at it, right? There is another product which is going to come up in Q4, which is Apache Pass, which fits in your DIMM slot. Okay. That has, in a current roadmap, you will see a 1 TB of capacity. And in Octane, you will see even in Q4, you will see 1.6 TB of a capacity, and in the next generation, you will see further, larger capacity coming up in Octane itself, which is a PCA form factor.
Okay.
So in a nutshell, your SSD would remain same, right? This is to address more on the memory issues and the memory tier of it.
Yeah, hi. So I understand the 3D, Optane uses 3D X-point technology, right?
Yes.
And even Apache Pass uses the same technology.
It's the same technology.
Okay.
The medium, we call it the medium, right? So the flash drive has a memory medium. That medium is a 3D Crosspoint technology. If you look at it, it's a crosspoint. The memory cells, the electron stores the bytes in the crosspoint. So that is where it is a 3D Crosspoint technology. And that is underneath technology being used both in Apache Pass and the Octane.
Okay.
So the medium is the same, your form factor is different. How you have a SAS drive and a NVMe drive, right? Similarly, here in Octane technology, you will be having, currently you have a PCIe form factor, and DIMM slot you will be having it in the future.
Okay. So you mentioned about the Intel memory drive technology, right? Yeah. Which uses Octane.
Yes.
And on the software layer, you emulate them as a RAM, right?
RAM, yeah.
So how do you compare that with Apache Pass? Because Apache Pass is directly going to give you a RAM interface.
Okay. So there is Apache Pass not exist at the market at this moment. Probably in a Q1 you will be seeing in the market. Probably in my view, if you ask me, there are three models, right? What the trade-off happening between the performance and the cost, right? You will have a SSD versus that cost model, and the 3D Crosspoint has its own cost model, and Apache Pass has its own cost model. And of course, all DRAM would also be play a role where, very mission critical application, it goes with the combination of Apache Pass and the 3D RAM. DRAM. So all it depends, there is a different cost models associated to that, and which gets trade off with respect to your performance and your tier of data temperature.
Okay, so you are saying that the software emulation of Octane as a memory is going to be a little slower than Apache Pass?
Yes, of course.
Okay.
Apache Pass doesn't require any IMDT.
Yeah,
okay?
correct.
Because that comes into the
that directly
slot.
goes into memory slot. Yeah.
I just
And-
want to be clear on that.
Okay. And one more question in your video, whatever you showed, right? One point was mentioned is it's going to be very cheaper than the DRAM. So
yes,
I think it was talked about Apache Pass, not Optane, right?
No, it is Octane.
Oh, Optane is going to be
So
cheaper.
I have none of this content talked about Apache Pass. Just I gave a one-liner insight to Apache Pass. All this talked about Optane technology.
Okay.
Right. So it's much more cheaper than the DRAM, and that is where the cost priority between the performance.
Okay. Last question is, you said there is a non-volatile memory library Intel has developed, right?
Yeah.
Is it for Linux or?
So this is to address the bottleneck on the NVMe application softwares. So it is available both in Windows and the Linux environment.
Okay, because yesterday we had a session on the persistent memory session, right? Where you have a pmem.io libraries, which are user space libraries. They also provide APIs to talk with the persistent memory.
Right.
So is this library provide the same thing with the different APIs, or how it complements that pmem.io libraries?
Okay, so this is underneath within that PMM library is part of this packages.
Okay.
Does that answer you? I mean, there are libraries architecture which fits on top of the NVMe.
Okay. 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 Yeah, I'm done.
Okay. Any question? All right. Thanks.